So, here generally factor of safety and other things need to consider very high, that you can say. Then what happens due to this high factor of safety, dimension or other things, that means thickness of the material and other things generally considered is little bit higher side. That is why it is generally bulky and large, I have written. That is why for some product component with short service time and infinite life design which will waste material as well as which will generally require more cost, you can say, that means which will be more expensive. So, the current trend you know generally toward mechanical part which should be generally lightweight and maintain and miniaturize generally has thus. So, the current trend of toward mechanical part being lightweight and miniaturized which has thus meant that there are limitation to the application of infinite life design. Now, we will discuss about the shape life design or finite life design basics in details. So, in shape life design this design method is generally is wide applicability, it is design method has wide applicability, that you can say, compared to infinite life design. The shape life design does not seek to make part have an infinite service life, but rather to make them have a limited fatigue life during which they will not experience any fatigue damage. That means, it will have a limited fatigue life, but what happens during that span of service life, it should not subjected to any fatigue damage. This is the criteria of this shape life design. This design method is based on, you can say, Minard's cumulative damage theory and S-N curve approach. So, this method you can say is the very important method. Here a very important techniques we use for cumulative fatigue life calculation, that is called Minard's cumulative damage theory, and here also we use S-N curve for prediction of service life of a component. Okay. Generally this Minard's principle consider that each stress implicated to a component and its resulting damage will be independent and the stresses will gradually accumulate. How? Everything in details I will discuss in subsequent lecture. Okay. So, here one thing you should keep it in mind, generally we observe that S-N curve, that means log stress versus log 10 number of cycle, there we observe that S-N curve generally looks like this, little bit this way I am just showing. So, generally this shape life design is more applicable within this zone. What I am saying, that means oblique part of, you can say, from A to B zone, you can say. And in horizontal part, this zone generally where generally infinite life design is used, that you know, because that part is after endurance strength. That is why you can say B towards C where generally infinite life design part is, infinite life design techniques is used, whereas in A to B part along this oblique part generally of this S-N curve, this shape life design is mainly used. This you should keep it in mind. Now, you see in Minard's rule also you should know, when the accumulation reaches a certain level, then damage will occur. So, what is this certain level? Everything in details I will discuss subsequently. Now, this shape life method is the most commonly used fatigue design method and it is widely applied in the fatigue life design of aircraft, ship and vehicles. This you should keep it in mind. It can make better use of material across a limited component lifespan. That means, here whatever that means it can make a component lightweight for its lifespan. What I mean, it's maintain the quality of the part as well as it's maintain the lightweight of the structure, which is generally this modern age requirement, you can say. this modern technologies requirement that it can fulfill. That is why this basic shape life design technique has a wide application in the field of fatigue design purpose. Okay. We will discuss now another technique that is called damage tolerance method. In this is a very interesting method. Here generally this damage tolerance method is proposed on the basis of actually fracture mechanics, and here also another aspects we need to consider, that is called the crack propagation equation. This approach consider generally a critical value of initial crack in a part. So, this is the main point, you should keep it in mind. Initially we need to consider a critical value of a initial crack in a part, then what happens, estimate the remaining life. In this remaining life, this crack should not expand, this you should keep it in mind. That means this crack will not expand, that means crack will remain as it is. That remain life generally you can calculate by damage tolerance design method. This damage tolerance method, first it can describe the stress field at the tip of the crack using a stress intensity factor, and another point you need to know, here this initial defect, critical size of the crack, which are generally determined through non-destructive testing. Okay. So, damage tolerance theory, it can predict the what is called stress field at the tip of the crack, and here another point you need to know, whatever the crack size, defect size we are calculating, initial critical crack length, that we need to calculate by some non-destructive testing. There are different types of non-destructive testing are there, like XRD, then what happens, ultrasonic vibration, then what happens, there are some other techniques like what is X-ray techniques, the different types of techniques are there, then some what is called acoustic techniques also are there. Using those techniques generally we need to find out what it is called initial defect, critical size. After that generally what happens, those critical size of initial crack in a part we need to observe, actually it should not, we need to observe in the sense we need to observe as well as we need to control not to expand. Based on this we need to estimate the fatigue life of that structure. That means here the damage will not expand or propagate, this you should keep it in mind. So, the remaining life of a part then calculate, and the fracture is controlled, which generally guarantee the part can work safely within a certain service period. Okay. Now, the fourth method of fatigue design is called durability design. In this design also this structure approach is generally considered, that you can say. They are generally the durability design first seeks to consider that the part that are mostly seriously damaged by fatigue, that part we need to consider here. That means we need to choose those part which is which can subjected to seriously damaged by fatigue. What are those part? Those part will be the discontinuous part, like what happen, those part can be what is called steps, some steps, those part can be some keyhole, those parts can be some arcs, what I am telling, understand. So, those part first of all we need to generally consider. After that generally what happens, from those part generally we need to take all possible cracks into consideration. Whatever those critical damage location we first select, in that location what we need to consider? We need to consider all the possible cracks available on those part, that means small to large size, and believing that a small crack whatever the things will be there, that will also gradually expand into crack defects. So, when this crack defects will form, then it will damage the what is called a structure, as well as it will damage the function of the product, what I am telling, understand. So, here what we need to consider, in previous categories I have told you that critical crack size generally first we need to consider, and that should not expand. But here in this case, whatever the crack size we need to consider, even the small crack also here it is considered, it is generally gradually expand, and in its what is called, it generally convert to a crack defects. Here the basic criteria of this durability design is, here always you should keep it in mind, here NHJ less than equal to NE. That means, whatever the life we will estimate based on this durability design, that is called NE, this should be greater than equal to NHG. NHG calls service life of that component. That means, whatever the service life of the component, it should have, our this durability design service life should be more than that, durability design life should be more than that service life of that component. This you should keep it in. So, this is the basic criteria of this design, that I have written already. NHG is the service life and NE is the durability life. Now, you see, these are the 4 important design method which generally used to design a component. So, we observe first one is infinite life design. So, infinite life design generally briefly I am just discussing. Here we observe that it generally though it is easy to design and it is the earliest technique, and what happens, we observe that this design generally makes the component bulky and heavy, which generally is not cost effective, that you can say. So, that is why what happens, this infinite life design is not nowadays popularly used in the fatigue life design purpose. Because now the modern technology generally want lightweight types of structure, which is not possible to design by infinite life design. Then finite life design we have seen, there we observe that this finite life design can reduce the or eliminate the problems associated with infinite life design. So, that is why this safe life design is popularly used in the field of fatigue life design. There we observe that they are also use S-N curve approach. So, generally this safe life design use the oblique portion of this S-N curve zone, whereas infinite life design generally use the horizontal portion of this S-N curve zone. Then we observe that this safe life generally can create a structure which is lightweight and it is also cost effective. Then after that we observe that damage tolerance design. In damage tolerance design we observe that this method generally we consider initially a critical size of initial crack length, and this crack length we generally control not to expand, and we estimate the rest of the life of that structural component or structural part, and based on this thing generally life estimation is done in damage tolerance method. Whereas, in durability method, here we first need to consider the most critical zone of a parts, that is generally arcs or steps or hole, and after that generally what happens, on this location we need to estimate all the possible cracks, or you can say that crack can be small to any size, and here we generally consider this small size of the crack or small size of the crack can expand and it can convert to a what is called crack defects. Once it convert to a crack defect, that generally will cause damage to the structure and it also damage the function of the product. So, and here the basis also I have already discussed. So, that this is the brief of this fatigue design approach. Okay. Now, some important notes need to know before going to discuss next topics. So, here you can see in fatigue topics we observe 2 different types of important factors generally we consider. One is called stress concentration factor, another one is called stress intensity factor. So, it create a confusion to the readers, you can say. That is why what happens, clearly we should know what is the difference between these two. So, first of all I have already discussed about stress concentration factor. So, stress concentration factor is observed where there is a abrupt change is there generally stress concentration is taken place. So, what we observe that stress concentration factor means due to this stress concentration, whatever the stress rise compared to nominal stress, that ratio that you can say is called generally stress concentration factor. That means maximum stress near the discontinuity divided by nominal stress obtained by minimum cross sectional area of that component. So, what we observe that there we observe that there are two types of stress concentration factors are there. One is called theoretical stress concentration factor KT, and another one is called fatigue stress concentration factor. This already I have discussed. Theoretical stress concentration factor also called elastic stress concentration factor, and Kf is called actual or fatigue stress concentration factor. So, definition here is given like Kt is the highest value of actual stress near discontinuity divided by nominal stress obtained by, you can say, elementary equation for minimum cross section, which I have already discussed in earlier lecture. And fatigue stress concentration factor generally is endurance limit of a notch free specimen and divided by endurance limit of a or endurance strength of a notch specimen. Generally this Kt or Kf both have a value greater than 1, you can say. So, stress intensity factor, which is a very important factor in the field of fracture mechanics, because we will discuss in this course detail about linear elastic fracture mechanics, where we will discuss about a very important fatigue life estimation method using Paris law. So, in this course itself I will discuss about Paris law in details. I will solve some problem on this Paris law also. So, this stress intensity factor generally G. Irwin, a researcher in 1957, who find that stresses around a crack in terms of a scaling factor. So, this stress intensity factor you can say is a scaling factor. It is established by G. Irwin. This you should keep it. This stress intensity factor you can define in terms of y sigma 0 square root of pi a. So, y is a generally geometric constant, or you can say geometrical factor, which I have already written. Sigma 0 is called remote stress, a is called generally you can say crack length. This you should keep it in mind. So, this is generally called stress intensity factor. Now, this stress intensity factor depends on different types of loading type. What I am telling, understand? There are generally you can fracture mechanics 3 different types of loading type you can observe. So, one loading type is tensile in nature, which is opening mode, another one is called shearing mode, another one is called tearing types of mode. So, these 3 different modes we observe. So, for 3 different mode this stress intensity factor is also different. So, here mainly this stress intensity factor which we will consider, that is generally you can say opening mode types of condition that we will consider in fracture mechanics approach. Okay. This you should keep it in mind. Now, here I am just going to show what is the difference between stress concentration factor and stress intensity factor, because these two things need to be cleared very clearly. What I am telling, understand, this you should keep it in mind. That is why I am going to discuss this thing little bit more details. So, I have already told you stress concentration factor generally is occur due to geometrical changes, where there is a chance of rising of stress. So, this is occur where there is holes, notches or fillet in a component. Here one thing you should keep it in mind, stress concentration factor generally does not depends on load condition, whereas I have already told you stress intensity factor is depends on both geometry as well as load. This you should keep it in mind. And this stress intensity factor, it is inherent property of material that is generally tested and defined for flaws and cracks. It is the inherent property of the material. Okay. Generally this stress concentration factor, it can have a value varying from 1 to 3, sometimes it is more than 3 also. Second point, you see stress concentration factor is a dimensionless factor, because it is the maximum stress by nominal stress. This ratio, stress ratio is there. What is stress concentration factor? I have already told you, this is generally sigma max divided by sigma 0. nominal stress. So, both is the ratio of stress. So, it is a dimensionless factor, it do not have any dimension. Okay. Whereas, generally this stress intensity factor has a dimension. Why? Because stress intensity factor you see it is generally y sigma square root of pi a. So, you see y is dimensionless, but sigma is generally you can say megapascal, and root over generally there is a crack length a. So, you can say MPa square root of meter, its unit. What I am telling, and megapascal is the stress unit and crack length unit is let us meter. Here in third point you need to know, to analyze the stress concentration, generally the stress concentration factor is required. At a particular location how much stress concentration is taken place, for that purpose generally you need to know what is the stress concentration factor, which is a critical parameter for safety of the component, you can say. For safety of the component, this is a critical parameter. For deciding the factor of safety, this is a critical parameter, that is stress concentration factor. Whereas, in stress intensity factor it is used generally in fracture mechanics, and it is used to calculate the allowable stresses. It is often used for fatigue calculation of metals. Now, another important point you need to know, this should not be confused to you during our this fracture mechanics topics also. Suddenly very frequently we use the term, one is called toughness, another one is called fracture toughness. So, what is toughness? The toughness generally is defined as the ability of a material to absorb energy. So, it is generally absorb energy per unit volume up to rupture point. This is generally defined as toughness of a material. This you can calculate, it is the area under this, let this is the stress versus strain curve. So, generally toughness is the area under the stress strain curve. Okay. So, this you can find out. So, this you can find out by integrating 0 to epsilon sigma into d epsilon. Now, how its unit is coming, joule per meter cube, that I am going to discuss. Like you see, you know this sigma unit is you can say force by cross sectional area, whereas strain unit is unitless, change of length divided by original length, this we can write. Okay. So, this if we will write, then what are the things we will get? What we can say, P into distance you can say work done, A into L its unit is meter cube, force into distance you can say, just for your understanding purpose I am just writing this, how this joule per meter cube is coming, from this equation itself you can get the idea, because toughness is the area under this stress strain curve, this is stress and this is strain curve you can say till rupture point. Whereas, fracture toughness is defined as critical value of the stress intensity factor, what I am telling, understand. That means, stress intensity factor K already I have told you y sigma pi a. When this stress intensity factor become critical K c, when it will be critical, you see once your crack length will be critical crack length A c, what I am telling you, understand. That means, once this crack length will be a critical size of crack length, then at that time whatever the stress intensity factor K you will get, that is called critical stress intensity factor. So, this critical stress intensity is generally known as you can say fracture toughness, this you should keep it in mind. So, fracture toughness is related to fracture mechanics and is defined as the critical value of stress intensity which leads to unstable crack growth or fracture, this you should keep it in mind. Now, toughness have a unit which is generally joule per meter cube you can say, whereas fracture toughness have a unit MPa square root m, this I have already discussed, this you should keep. So, this is the main difference between fracture toughness versus toughness. Okay. Now, these are the references which I have followed for preparing this lecture. Thank you.